A few months ago, I started a new position at Meetup, and part of my onboarding was to review the backend architecture. And I started to come across designs that looked a bit like this, and there were basically just lambdas everywhere in their architecture. And I had a vague understanding of what they were, but nothing really too deep. And it made me more curious. So this is our first poll. How many folks here are familiar with lambdas? And I'll just pause while Johnny gets that going for you all. And can you yell out the results for me?
Yeah, so we are a good number of votes, and it looks like about 60% are somewhat familiar. We got a handful that are very familiar, and then a couple that are not familiar.
Okay, cool. So we have a nice mix. At Meetup, we had over 1,400 instances of lambdas in production. That fact alone made me decide to really wrap my head around this technology. And my goal today is to help impart what I've learned so far to help you get started with your own serverless explorations. One of the key things to note about lambdas is that they're just one piece of what makes up the serverless landscape. I have to give props to Amazon because in many circles, Lambda is synonymous with serverless, but it's not actually a one-to-one mapping. Serverless encompasses storage solutions and so much more. So let me see, I want to make sure I'm still sharing my screen. Yeah, and it's things around authentication, queues, IoT, everything is in serverless. Now, here's how I like to think about the different buckets of serverless services. And so there's four main things which actually are vendor agnostic. There's things like compute. This maps to functions. And of course, on AWS, that's handled by Lambda. Next is storage, things like files and raw data. On AWS, you can think of S3 or DynamoDB, which maybe some of you are very familiar with things like S3, for example. There's streaming with messages and queues. AWS has SNS, known as the Simple Notification Service, and also SQS, Simple Queuing Service. It's just some examples. And then finally, we have querying like ETL, SQL, and ML. And on AWS, there's tools like Rekognition that handle image and video analysis based on machine learning. But what is serverless exactly for those who are not very familiar? Does that mean that your code just runs in the air? No. It's mostly encompassed by three things. You don't have servers to manage and provision. You pay for what you use. So you may be used to running EC2 instances and getting billed on an hourly or monthly usage, but this type of billing happens on the millisecond level. And finally, scalability is provided by the vendor. You don't have to set up load balancers and auto-scaling groups or just like get the perfect health check triggers just right. All of that is handled for you behind the scenes. When we think about the landscape of serverless architectures, it runs from two extremes, on-premise servers all the way over to cloud native. Cloud native is this type of ideal where your entire architecture is based off of events or triggers and take advantage of serverless services. It's very similar to this diagram that I showed you earlier. You have a trigger, the user taking some sort of action on their device, and then there's this cascade of interactions that involve serverless services. The key players in the game are Amazon with AWS, Google, the Google Cloud Platform, IBM has their own platform, and then also Microsoft Azure. But what is it that they're promising us? The main pros are a faster time to market because you don't have to worry about all of those sort of DevOps things, cost savings, simplified scalability, and then there's no specialized DevOps person. So just regular engineers can work on serverless services. But it does come with some real cons, such as the fact that the ecosystem is fairly immature. I think Lambda came back out in maybe 2014, I think it was. So it's really not that long. You get vendor lock-in. Typically, if you decide to go with AWS, you're using their serverless services for all the things. And the same could be said of like Microsoft or Google as well. You do have multiple moving pieces. If you think about that diagram that I showed you, there were all these different connection points and you have to kind of get it just right. And then finally, there is a learning curve. If you are used to just deploying your monolith application, now trying to think in a serverless way, it takes time to really learn what's available and adjust the way that you are architecting your systems. So in an ideal world, developing applications that take advantage of serverless services means that there should be less. Like there should be less backend code, less complexity, less risk, and less tech debt. Now, whether or not that's true is based on where you are in your learning curve, but this is the ideal thing that serverless is trying to promise to us. So how can you get started? My recommendation is to create an account on AWS with the free tier. All of the major players have a very generous free tier, which allow you to experiment with serverless on your own. I chose AWS because that's what we use at work, and it is by far the key winner of cloud compute at this time, so it's not a wrong way to go. Once you're using something like AWS Lambda, you can create Lambda functions via the AWS Console. And you have a few options to do that, either from scratch using a blueprint or via a repository of Lambda apps. So let's take a quick look at the console just to see some of the options available. Okay, and hopefully you see the console now. Is that true?
Yep.
Yep, cool. Okay. So this is my AWS console. I'm logged in with my free account, and I'm going to go click on Lambda. And once that loads, you see this big orange button where I can create a function. And then I have different options. I can either create one from scratch, use a blueprint, or look at a serverless app repository. So let's say I want to use a blueprint. You can search in here, and there's so many ones available. Things for Node, different versions of Python. I mean, it just kind of goes on and on. A microservice endpoint. And then you have the option of configuring your Lambda right here from the console. Okay. And as you saw probably briefly, there are loads of services available from the cloud providers. This is just a snippet from AWS of what they're offering. It definitely can be overwhelming. And almost every time I check back, there's like one new thing that they've added. And here's the same thing from Google. You kind of see there's things around the networking and how your security and identity is done. And it just goes on and on and on. Essentially, you need to be a good detective. As you're building your application, you have to constantly check back to see what's available because it could impact the final solution that you choose. And remember, for the cloud native is like the ultimate experience. You want to try to take advantage of as many serverless services as possible. But another thing to keep in mind is that although you're running serverless things and it can be very cost effective, it's not free per se. You can use a tool like this serverless cost calculator to get a sense of what your application will cost you. For instance, it costs me 50 cents to run my sample application that we're going to take a look at soon, but that's because I have an API gateway, CloudWatch, and Lambdas, and everything combined. But if you're going to do some real production level system, you want to be able to get a sense of how much it would actually cost. Now that we've seen how we can use the console to deploy our application, that's not actually the recommended approach. You don't want to use the console and you want to take advantage of configuration instead. A platform agnostic way to do that is by using Terraform. Terraform is an open source tool that lets you create infrastructure via code. If you've never seen it, here's a snippet from a Terraform file. It has its own DSL for specifying the resources and data that'll be needed by your serverless application. As I mentioned, for my serverless application, I'm using API Gateway, and this is how we're defining what that infrastructure would look like in Terraform. However, it's worth noting that each of the different cloud providers has a proprietary way of doing something similar. AWS has CloudFormation, and Google has the Cloud Deployment Manager. And then here's just a visual tool provided by AWS for creating CloudFormation templates. So you kind of see you can drag and drop, and then in the bottom, it gives you the resulting code. Ultimately, creating serverless applications requires a mind shift. Testing in production, focusing on split testing, preemptive load testing, observability of your system. There's this whole kind of shift that you need to make when you're really thinking about going all in on serverless design and architecture. And you want to have unit testing in place and using that as the thing to merit a deployment to production. So just kind of shifting the way you might think about a typical deployment of a monolith application. Now that you have some foundational knowledge, let's take a look at serverless with Kotlin. We're going to focus on three main libraries: KTour, Coin, and Cutlass. The goal is to create a GraphQL API that exposes UFO sighting information. First up is KTour. KTour is the application framework that we're going to use. You can think of it a bit like the Spring framework that has been used for decades to deliver like Java-based applications. KTour has an application class, and then inside of that class are features. Normally, these features can intercept requests or responses and perform some sort of action like adding headers or changing the content type. And then there's also this concept of routes. The routes are used to provide handlers to act upon different request paths. So let's look at an example. In this KTour app, there are two routes. The first one is a GET request against the root path. And then the second one is a POST request against /GraphQL. And then everything else will return a 404. Inside of the route is the code that you want executed. So in the first case, I want to go to the index page. And then in the second case, I want to take the data that I get from the GraphQL call, make my request, and then respond with some sort of result. Moving on to Coin. Coin is a lightweight dependency injection framework for Kotlin developers. It's written in pure Kotlin, so no proxy, no code generation, no reflection. Really simple to wrap your head around. If you're like an Android developer, you're probably familiar with Dagger. It's way more complicated, complex. So if you're doing something simple, Coin is my go-to. This is how you would use it to inject dependencies in your class, and it's just perfect for simple things like this. Finally, the star of the show is Cutlass. Cutlass is a Kotlin serverless framework. It works by doing the following: downloading Terraform, generating deployment code, packing up your Lambda, and then deploying it to AWS. Here's how KTour and Cutlass work together. The normal application class that you use for KTour would extend the Cutlass base class and then define some routes. That's it. In your build.gradle file, there's going to be a configuration section for the Cutlass plugin. And this is where you would provide some basic information to help Cutlass generate the correct infrastructure code using Terraform, which was that strategy that we saw earlier. So here I have some bucket, DSL where I'm putting my AWS information, And then this is where my Lambda code and config is deployed, which I will show you momentarily. And then finally, for now, the last time I checked, you had to set up a Route 53 with a domain in order for Cutlass to work. I won't go through the entire process of how I set up that domain, but it's all in the documentation. And then you run deploy. And within seconds, you have a Lambda ready to go in AWS. And this is just what it looks like when you open up the console. And here's my running app. So this has the ability to, at the top, you'll see api.ktour.cutlass. That's my endpoint. And then I can make GraphQL requests against it and get back the results. So it might seem kind of magical at this point. And for someone new to serverless, I was just really impressed that I could deploy something in Kotlin with minimal effort. But if you're curious to look behind the scenes, it's not that magical at all. The plugin parses your code in conjunction with that information you put in the config DSL, and it generates a Terraform template for you. This template has everything needed to deploy a RESTful application, and it's all there inside of your build folder. And this is just a snippet of the Terraform template that was generated for my sample app. So let's take a quick look at the sample app so you can kind of wrap your head around a bit more what I'm talking about. So this is here in IntelliJ, and here's my entire Terraform template. It kind of goes on a bit, but you can get a sense of what the plugin is doing for you. You don't necessarily have to write all of this down. It's creating everything you need to deploy your app. And then if I go back up to the top, okay, let me try to change the view. Where's my, yeah, here we go. Okay, is that better? I'm monitoring the comments, so if someone gives me a thumbs up, then I'll assume you can see it better. Yay, okay. Cool. So here is the main KTour application class. Kind of ignore the red stuff. I don't know why IntelliJ is doing this to me today, but you'll see that it extends the Cutlass base class. And then inside of the prepare function is just the main and the routes. And so for main, we're installing the features. So I said KTour has a lot of features that you can do related to headers and call logging, and also the output, which we're using JSON for. And then the routes is the main piece that we want to focus on. So I'm going to kind of exit this for a second. And I want to get back to, is the compression? Okay, I see. Yeah, it's probably a bit harder to see, but I just want to show one more file. The routes, okay. So here inside the routes, you'll see the post to /GraphQL. And this one takes in my GraphQL requests, grabs the query and any variables, and then we're using KGraphQL, which is another Kotlin library, in order to execute whatever the GraphQL query is, and then send it back to them as some JSON, which is pretty cool. And then the final thing, which I think is probably interesting here, is how we're setting up the GraphQL schema using KGraphQL as well. So you can have access, all of the sample code is available, and I'm going to make sure I share the link. But then the final thing to see is if we go back to Lambda, really slow. Here is my sample app. And you can see that it's composed of API gateway, as I mentioned to you. And then we can kind of dig in here and then see that it has just /GraphQL and then that main endpoint, which is the Git. So it's kind of interesting to see how this is all happening in code, and then I can go to the Amazon console and see the results of my work. You can grab the sample app from here if you just want to follow along. I'm mostly just getting started. This app is pretty much a monolith deployed as a Lambda, which is very bad. And I want to move it to a more standard serverless architecture using DynamoDB as my data store, and then running that off of an S3 push event. So there's a lot more that I can do to make this a true serverless application. And if you're just curious, whenever I have free time, who knows, I will try to update this branch of this project to do that. But finally, I just wanted to spill a little bit of tea, just my personal observations of working at a company that uses so many Lambdas. The interesting bit is that when you have multiple Lambdas spread across multiple teams, sometimes it can be tricky to figure out, well, who owns this Lambda, especially if you have some attrition or you have turnover or people swapping teams or moving on. As an Android developer by trade normally, I'm just thinking, okay, which project do I look at to find that endpoint? But the endpoints could be in multiple different projects, multiple different repositories, and it's kind of tricky to know exactly how to track it down. And then it doesn't seem like people have the same sense of ownership over a Lambda endpoint as they would an entire application. Where I don't know if that's just like how it has happened at my company, or if other people have experienced something similar who work with serverless a lot. But I don't know, it's just like something feels a bit different about having the Lambdas, and it's not always super intuitive how to go from consuming endpoint to finding out the source code and everything that happens in between, especially if you're relying on events to trigger actions that lead to other Lambdas getting involved. So the kind of debugging and tracking down of things was much more challenging for me than I was used to with like a more standard monolith application. But I'm definitely very curious to know if other people have felt the same, or if you've even found solutions to that sort of issue. I have a ton of resources that I use as a reference for this presentation, and I have even more just like interesting facts around serverless solution architectures and things that you want to keep in mind if you go completely cloud native. So I'll make sure these slides are on speaker deck, and I'll make sure to share the link on the Meetup page. And then, yeah, I just would thank you for having me, and I'm willing to take any questions.
Hey, Annyce, so there's 3 questions in the Q&A right now. The first one is from Jared, and he says, knowing that the answer to most questions is usually, quote, it depends. With that in mind, if I had to choose between spinning up an EC2 instance versus using a Lambda, when should I use one or the other?
One or the other. Okay. So if you already know what you're doing and you need to do it quickly, spin up an EC2 instance and get on with it is what I would say. But if you need to do something like a user takes a photo and you have to do large scale image classification for millions of users, use a Lambda, because there's already Lambda services out there that do image classification, and you may end up writing just a teeny bit of code And you can keep taking advantage of the improvements that come along in machine learning that get adopted by that particular serverless service versus you trying to write your custom implementation on your own. So the first thing that I would do is say, what am I trying to do? What's the scale? What is the time constraints? And what do my funds look like? So you kind of have to keep asking yourself like scale, time constraints, and funds, and also what you know. If you are already a machine learning expert, then maybe you do want to write your own models. But if not, then it would be easier to go with a Lambda.
Awesome, thanks. The next question is, how does the Lambda service in AWS compare to the Cloud Function service in GCP?
That's a good question. I mean, from what I can tell, people are very happy with the Google Cloud Functions, but Amazon is adding more and more services very quickly that link with their Lambdas. So if I I would just say that it depends on the needs of it. It really does depend. If your team is already using Google Cloud, then it might make sense to stick with that for your functions versus moving to AWS. But I feel like from what I've read, it's very similar. I've never worked with the Google Cloud Functions personally because my company is such an Amazon shop. But from like this raw specs, I think it's very, very similar.
Great. And the third question is, if you use AWS Lambdas, have you found issues with the slow JVM Lambdas as opposed to Node.js? And then there was a follow-on there about Python as well.
The JVM Lambda thing is real, especially like the warming up time. I think that Cutlass is like a beta product, but even the maintainer is pretty active in the Kotlin Lang Slack. And I think recently he was working on something to try to help improve that for the JVM. When it comes to the slowness, we were probably talking like seconds or like milliseconds. So it depends on your needs. I mean, for my sample project, right, like I didn't really care, but in production, it might be a real concern. But I just know that it's getting better. As I was showing that slide where everything was scrolling, literally every time I check, they add something else. Like that's just how quickly they are improving on it. It's really impressive. Any other questions?
I don't see any more questions in the Q&A, but if folks have any, they can put them in the chat.
Okay. Well, just thanks to everyone for coming. This was really fun for me. I love doing this. I miss getting a chance to talk about Kotlin, some of the cool things that are going on. So if people, someone said, what's the best way to contact me later? Twitter. I'm super active on Twitter @BrownGirlDev. You can reach me there, and I can help answer your questions. Let me just type that in the chat. And thank you very much.